Hello students, welcome to my class. In today's class, we will continue with the chapter Trigonometric Functions of class 11. In my previous video, we have completed 5 questions of exercise 3.3. Today we will see the 6th question. Question number 6, prove the following. So question number 6 is cos pi by 4 minus x into cos pi by 4 minus y minus sin pi by 4 minus x into sin pi by 4 minus y is equal to sin x plus y. So this expression, if you simplify, you should get sin x plus y. So now we will start with the left side expression. So LHS, what we have in the LHS, cos pi by 4 minus x into cos pi by 4 minus y minus sin pi by 4 minus x into sin pi by 4 minus y. Now you see this expression, this is of the form. Can you find out any identity, similar identity? What we have already learned this is cos x cos y minus sin x sin y. So this is of the form, this expression is of the form cos x cos y minus sin x sin y. So what is that identity? Cos x plus y. What is the formula for cos x plus y? Cos x cos y minus sin x sin y. So this expression is in this form. Okay, so instead of this, what we can write? Cos x plus y. So what we have in the place of x, we have pi by 4 minus x, and in the place of y we have pi by 4 minus y. So instead of this expression, we can write cos of x plus y, that is pi by 4 minus x plus pi by 4 minus y. Now we will simplify this, that is cos, what is pi by 4 plus pi by 4? Pi by 2. So we can write pi by 2. From these two we will take minus sign outside. So minus of x plus y. So we can write this as cos pi by 2 minus x plus y. Now we have already learned what is cos pi by 2 minus theta. Cos pi by 2 minus theta is sin theta. So here if you see cos pi by 2 minus, in the place of angle what we have? X plus y. In the place of theta we have here x plus y. So instead of that, what we can write? Sin x plus y. This is what we have to prove, which is our RHS expression. So this is what we have to prove. Now we will see the next question. Question number 7. Tan pi by 4 plus x by tan pi by 4 minus x is equal to 1 plus tan x by 1 minus tan x the whole square. So we have to simplify the expression, this expression, and you should get answer as 1 plus tan x by 1 minus tan x the whole square. So we will start with the LHS expression, that is left side we have tan pi by 4 plus x divided by tan pi by 4 minus x. So here we will use the identity. Which identity we will use? Both numerator and denominator. Tan x plus y. So what is the formula for tan x plus y? So tan x plus y is equal to tan x plus tan y divided by 1 minus tan x tan y. So this is the formula for tan x plus y. Now the denominator is tan x minus y. So what is the formula for tan x minus y? X minus tan x minus y is equal to tan x minus tan y divided by 1 plus tan x tan y. So all these formulas you have to remember. So these two formulas we are going to apply, both numerator and denominator. So using that formula, what we can write? Tan pi by 4 plus tan x divided by 1 minus tan pi by 4 into tan x. So we have applied the formula in the numerator. So numerator we have applied the formula. Now denominator also we will use the formula. So tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x. Now we will simplify here. So what is tan pi by 4 value? You know that tan pi by 4 is 45. So tan 45 is 1. So here in this place we will substitute 1. So 1 plus tan x divided by, here if you see in this place if you substitute 1, we will get 1 minus tan x. Okay, the whole divided by, here also in this denominator also in the place of tan pi by 4 we will substitute 1. So 1 minus tan x divided by 1 plus tan x. Now you see here this term, that is this is in the denominator, so it will go to numerator, and these two terms are in the denominator, it will come in the denominator position. Okay, so we can write 1 plus tan x, already we have in the numerator, and this also will go, so you will get 1 plus tan x into 1 plus tan x, that we can write as 1 plus tan x the whole square, and denominator you will have a 1 minus tan x the whole square. So we can write this as 1 plus tan x by 1 minus tan x the whole square. So this is our RHS, this is what we have to prove. So question number 8, cos pi plus x into cos minus x divided by sin pi minus x into cos pi by 2 plus x is equal to cot square x. So here in the left side expression when you simplify, you should get the answer as cot square x. So here in this left side, if you see, here we have to first find out these values, that is cos pi plus x, sin pi minus x, cos pi by 2 plus x. So all these values we will find out first, then we will substitute in the left side expression. Okay, so we will start with LHS. LHS is cos pi plus x into cos of minus x divided by sin pi minus x into cos pi by 2 plus x. Now we are going to simplify these three terms separately. Okay, so first we will take cos pi plus x. So if the angle is expressed in terms of pi, I have already told you this pi value lies on x-axis. So if the angle on x-axis, the trigonometric function will not change. So the cos function will be the same cos function. Now you have to check the sine. Pi plus x. So we will draw the quadrant y dash. So first quadrant, second quadrant, third, fourth. Okay. So pi plus x means which quadrant? Third quadrant. So you have to check whether third quadrant cos is positive or negative. All silver tea cups. So third quadrant, tan and cot only positive. Tan and cot. Tan x and cot x are positive. All other trigonometric ratios are negative. So here we can write minus. So cos value is minus in third quadrant. So cos pi plus x value is minus cos x. Now we will see what is cos of minus x. This formula we have already studied. Cos of minus x is cos x only. Now next one, sin pi minus x. Sin pi minus x. Again pi is an angle on x-axis. So for angle on x-axis the function will not change. So we can write sin x, sin function as it is, that is sin x. Now we will see the sine of this function. Okay. Pi minus x. Pi minus x means which quadrant? So if you fully complete up to, if you reach here, you will get second quadrant, that is pi value. Pi minus x means it is in second quadrant. In second quadrant, sine is positive. You know that in second quadrant, sine is positive. So this will be plus sine x. Okay. Now the last expression, that is cos pi by 2 plus x. See here pi by 2. Pi by 2 is an angle on y-axis. Pi by 2 and 3 pi by 2 are angle on y-axis. If we have angle on y-axis, then you have to write the co-function. Okay. If co is there, then cos will change us into sine function. So sine x. So cos pi by 2 plus x is sine x. Now we will see the sine. So pi by 2 plus x. Pi by 2 means y-axis plus x means second quadrant. In second quadrant cos is negative. So here we will get minus sin x. So we have found the values of all these expression. Now we are going to substitute these values. Cos pi plus x is minus cos x into cos of minus x is cos x divided by sin pi minus x is sin x into this is minus sin x. So this minus sign will get cancelled and you will have numerator cos square x by denominator is sin square x. So this we can write as cos x by sin x the whole square. The cos x by sin x. What is cos x by sin x? Cot x. So we will get the answer as cot square x, which is our RHS. So this is what you have to do. Children, here when you simplify, you should be very careful the sign of the trigonometric function. According to the quadrant you have to. So you have to see this ratio only. So third quadrant means whether cos is positive in the third quadrant you have to check. You have to check cos only. And here sin ratio and here cos ratio. So according to the ratio in the quadrant you have to put the sign also. Okay, now next question. So question number 9. Cos 3 pi by 2 plus x into cos 2 pi plus x into cot 3 pi by 2 minus x plus cot 2 pi plus x. So this expression is equal to 1. So you have to simplify left side and you should get the answer. So question number 9. Cos 3 pi by 2 plus x into cos 2 pi plus x into cot 3 pi by 2 minus x plus cot 2 pi plus x is equal to 1. So you have to prove this left side expression. When you simplify, you should get answer as 1. So how to prove this? So we will start with the left side expression. LHS is equal to cos 3 pi by 2 plus x into cos 2 pi plus x into cot 3 pi by 2 minus x plus cot 2 pi plus x. So here in the left side, if you see all the expression, all these 4 expression, you have to simplify and find out its value. Then we will substitute and simplify. So first we will draw the quadrant. It's x dash, y dash. Here first quadrant all positive, second quadrant sin positive, sin x positive, third quadrant tan positive, fourth quadrant cos positive, cos x positive. So first we will take this expression, that is cos 3 pi by 2 plus x. So here the angle 3 pi by 2, you know that pi by 2 and 3 pi by 2, these two angles lie on y-axis, and for the angles on y-axis the trigonometric ratio will change. So the cos will change into sin, so you can write as sin x. Now we have to see this angle is in which quadrant. 3 by 2 means it will complete 3 quadrant, and 3 by 2 plus x, that is it is in the 4th quadrant. So in 4th quadrant cos is positive, so this cos only here we have. So this is plus sin x only. Okay. Now we will see the second expression, that is cos 2 pi plus x. So this is, you already know, cos functions and a sine function will not change for an integral multiple of 2 pi. So here cos 2 pi is on x-axis. The angle 2 pi lies on x-axis. So the value will not change. Trigonometric ratio will not change. And here 2 pi plus x means one full complete revolution is 2 pi. And again x means first quadrant all positive. That means cos is also positive. Here all positive. So cos is also positive. So you will get plus cos x. Now we will take this expression, that is cot 3 pi by 2 minus x. Again this pi by 2 lies on y-axis. So the ratio will change. Trigonometric ratio will change. Cot will change into tan. So we can write tan x. Now you see the quadrant where 3 pi by 2 minus x angle lies. So 3 pi by 2 minus x means this third quadrant. The angle lies in the third quadrant. In third quadrant, tan and cot, its reciprocal cot are positive. So we can write here plus tan x. Cot is also positive in the third quadrant. Now we will see cot 2 pi plus x. Now this 2 pi lies on x-axis, that is trigonometric ratio will not change, so we can write it as cot x, and 2 pi plus x means it is in the angle is in the first quadrant. In first quadrant all trigonometric ratios are positive, so cot is also positive, so we can write plus cot x. So all these four values we are going to substitute in the left side. So cos 3 pi by 2 plus x we got as sin x. So sin x into cos 2 pi plus x is cos x. So sin x into cos x. Within the bracket we have tan x plus cot x. Now we will simplify this. In the place of tan and cot we will substitute the formula. What is tan x? Tan x is sin x by cos x. So in the place of tan we will write sin x plus sin x by cos x, and in the place of cot x we will write as cos x by sin x. Now we will take LCM and we will simplify the expression inside the bracket. So sin x cos x we will take as LCM. Okay, sin x cos x. So when you take sin x cos x as LCM, here you will have sin square x plus cos square x. Now you see here this sin x cos x and sin x cos x will get cancelled. Now what you have? Sin square x plus cos square x. So what is this? Is an trigonometric identity. Sin square x plus cos square x value is 1. So this is our RHS. Value of this expression is equal to 1. Now the next question. Question number 10. Sin n plus 1 into x into sin n plus 2 into x plus cos n plus 1 into x into cos n plus 2 into x is equal to cos x. So here left side expression we have, what is the left side expression? We have sin n plus 1 into x into sin n plus 2 into x plus cos n plus 1 into x into cos n plus 2 into x. So we have to simplify this expression and we should get answer as cos x. So here the expression, if you see, this is of the form cos x cos y plus sin x sin y. So this expression is of the form cos x cos y plus sin x sin y. So this is the identity cos x minus y. You know that what is cos x minus y identity? This is nothing but the expansion of cos x minus y. So we will use this identity. So here in place of x we have n plus 1 into x, and in place of y we have n plus 2 into x. So we can write this as cos n plus 1 into x minus n plus 2 into x, that is cos x minus y. Now we will simplify this, which is equal to cos nx plus x minus nx minus 2x. So here nx will get cancelled and you will get cos x minus 2x, that is cos of minus x, which is equal to cos x. You know that cos of minus x is equal to cos x, so we got the right side. So RHS expression we got. So today we have completed 10 questions in exercise 3.3. The remaining questions we will see in my next video. If you like my channel, you can share and subscribe. Your subscription my motivation. Thank you students.